Hi AP Stats. We are going to be going through some more notes today since I am not in class today. So we are picking up on page 6, I believe, where we left off. And we're going to talk about the two calculator commands that we're going to use in this chapter. And so the one of them we have already seen, okay, which is normal CDF. So I'm just going to abbreviate that NCDF. And what we put into normal CDF is, like what goes in that calculator command is a z-score. Okay, we put, whatever z-score to positive infinity or, in between two z-scores, whatever it is, it's a z-score that goes into normal CDF. And what comes out is the area under the curve. So the area, or the percent of proportion under that curve. So that's what we get out. The other calculator command that we're going to use, which we're going to start using, is called inverse norm. Okay, and so mathematically, when we talk about an inverse, we're doing the opposite. Okay, so it's going to do the opposite thing. So inverse norm, it's going to take the area under the curve or the percent and put out the z-score. Okay, so it does the opposite. Okay, inverse norm does the opposite. It takes the area or the percent and you gives out the z-score that we're talking about. So we're going to use that in this example. Okay. All right. As reported in Runner's World magazine, the times of finishers in the New York City 10-kilometer run are normally distributed with a mean of 61 minutes and a standard deviation of 9 minutes. So again, I'm going to keep track of things. Normally distributed, we have our mean of 61, standard deviation of 9 minutes. Okay, so what would be needed to be in the fastest 10% of runners? Okay, so let's start with a curve here so we can kind of picture what we're talking about. So we said it's normally distributed, so we've got a normal curve. The mean, it's centered at 61. So with race times, where are the fastest runners? Okay, you got to think about this. Are those times going to be lower than 61, or are they going to be higher than 61? Well, in a race, you want to be fastest, so you want your time to be small. So the fastest 10% of runners is going to be down here, this left tail, wherever this 10% is, okay? So what they're telling us is this amount shaded in is 10%. And what we want to find out is what is this time that's needed to be that cutoff to be in the fastest 10% of runners. Okay, so notice we have this, we know the percent, we want to go backwards and find the value in terms of the problem. So this is how we're going to use inverse norm. So inverse norm always does the percent to the left. So this percent from this cutoff, down this direction to the left. So it works perfect in this problem. So we're going to do inverse norm of 0.1, okay, for 10%. So in your calculator, you're going to go, it's right by normal CDF. So you're going to go to second vars and go down to number 3 is inverse norm. So you're going to do inverse norm 0.1. Okay, and you're going to get that out of your calculator. It's going to be negative 1.282. Okay, if anyone has calculator difficulties, please just pause this, help your neighbor figure out if they can't find the calculator command or whatever they need to do to figure that out. Okay, so inverse norm 0.1, negative 1.282. What we know is our z-score formula. Okay, so inverse norm puts out a z-score. Our z-score formula is our value minus the mean divided by the standard deviation. Well, this just stuck out a z-score, so we have this. We also are given the mean and the standard deviation in the formula. So what we're going to solve for is x. Okay, so we're going to plug these things in. We don't know that value, but we do know the mean is 61. The standard deviation is 9. Okay, so to solve this, you're going to multiply by 9 and then add 61 to the other side. So go ahead and solve that. Just mathematically, you don't have to show any work from this point. You just do it in your calculator, it's fine. But you find that value. Okay, so go ahead and do that. And we should get 49.462. Okay, so that is this value in terms of the problem. 49.462 minutes. That is the time you would need to be in the fastest 10% of runners. Okay, so that's all we're going to say. A runner would need a time of 49.462 minutes to be in the fastest 10% of runners. Okay, for this race. Okay. Okay, for the New York City 10-kilometer run. All right, so B is very, very similar. What time is needed to be in the fastest 30% of runners? So again, we have our curve. The normal curve, we're centered at 61, but now we're shading in more of the curve. It's 30%. Okay, so this is 30%. We're going to do inverse norm of 0.3. Okay, so use your calculator. Second vars to go to distribution, get 0.3. Okay, so we should have negative 0.5244. And again, we're going to use our z-score formula. This is a z-score, so we have negative 0.5244 equals the value we don't know minus the mean of 61 divided by the standard deviation. So again, we're going to take that times by 9 and then add 61. So our value is 56.28. Well, that's fine enough. It depends on how many decimal places you use for your z-score. Okay, so a runner would need a time of 56.28 minutes to be in the fastest 30% of runners. Okay, so fastest, we're looking at the lower side. This missing z-score, or this missing value of where this happens, is at 56.28. Okay. Okay, and then when we flip the page, the next question that it asks goes with inverse norm a lot. And instead of the fastest times on the low side, it's asking what time is needed to be in the slowest 25% of runners. Okay, so we've got our curve. We're at 61. So the fastest, we're on the low side. This question is asking for the slowest 25% of runners. So the slow runners are the ones that have the longest times. And so those are going to be up here, where this, whatever this amount shaded in, turns out to be 25%. Okay, so we want to know, what is this cutoff value for where the top is 25%? Okay, inverse norm only does the percent to the left. So we want to find this cutoff where there is 25% to the right, but that means what percent is to the left? Do we see this? 25% is what we're after on top, this high 25%, Inverse norm only does the percent to the left. So the percent to the left is 75%. Okay, so there's 75% up here. We're going to find this z-score right here where it cuts it, the data where there's 75% to the left, the top 25% to the right. Okay, so again, we do this because inverse norm only does the percent to the left. There's no way to like fix that. So that's all we're going to do. Inverse norm 0.75. So again, go ahead and find that in your calculator. So you're going to get 0.674. We're going to set this up with our z-score formula. That's a z-score. We're going to find the value. The mean is 61, and we're dividing by a standard deviation of 9. So multiply by 9, add 61. Go ahead and solve that. So we get 67.066 minutes. So they would need a time of at least, this is this minimum value here, 67.066 minutes, and above is going to put you in the top 25%, or the slowest 25%. Okay. So a runner would need sorry, my phone's ringing in the background. A runner would need a time of at least 67.066 minutes to be in the slowest 25% of runners. Okay. Okay, number 10, using the data from example 7, heights of 5-year-old children in centimeters, here's this notation, n with 100,6. So that means that it was a normal distribution with a mean of 100 and a standard deviation, okay, of 6. That's what that notation means. So this is a very common question to see. What height would classify a 5-year-old in the 95th percentile? Okay, so we're talking about percentiles. So again, by definition, think about what a percentile is. A percentile is the percent to the left. Okay, so here in this distribution, we're centered at 100. We want to know where is the value, how tall would you have to be in the 95th percentile? Well, that means 95% of people are below you. This is 95%. Okay, so do you notice what we're given? Are we given a z-score or are we given a percent? Here we're given a percent. So which calculator command do we need to use? Okay, you're going to have to choose between the two. We know a percent, so we're going to be doing inverse norm. We want the percent to the left, so that's great. So we just get to stick in 0.95. Okay, so use your calculator. Second distribution, go down to inverse norm, 0.95. This puts out a z-score. Okay, 1.645. I don't know, I just used more decimal places just because I did, but 1.645 is fine. Equals x minus our mean of 100 divided by our standard deviation of 6. Okay, so multiply by 6, add 100 to solve for x. So our answers might be slightly different just with rounding, which is fine. But this should be like something like 109.869. And our units were centimeters, so this is centimeters. So you would need a height of 109.869 centimeters would classify a 5-year-old in the 95th percentile. Okay. Okay, part B. What is the percentile for a 5-year-old child that is 87 centimeters tall? Okay, so we're still centered at 100. So 87, we don't quite know how low that is, but it's on this side somewhere. I just don't know graphically how far, to draw that, but I don't know the z-score. So this one's a little bit different. Here we have, do we know the percent? No, we're asked to find the percentile. The percentile, again, is the percent to the left, lower than. So we just want this percent that's lower than 87. So our answer is the percent. Which calculator command should we be using to get an answer that's in terms of percents? Okay, you got to choose between inverse norm and normal CDF. To get out a percent, you're going to be using normal CDF. Okay. Before we do normal CDF, I can't just stick 87 in there. Normal CDF needs a z-score. So we're going to find a z-score for 87. So 87 minus 100 divided by our standard deviation of 6. Okay, so go ahead and calculate that. Okay, we should have negative 2.167. Then we're going to use normal CDF. Here, our left bound, we're starting at negative infinity, like the number line, and we're going up to negative 2.167. Okay, so use your calculator to find that. Okay, so we should have 0.015. Okay, so that means, well, I guess my graph is drawn a little bit off. In percent, this is like 1.5%. So obviously I didn't quite draw that super well because it looks like more than that's shaded in. But, so this would be the 1.5th percentile. Okay, so a 5-year-old that is 87 centimeters tall would be in the 1.5th percentile. Okay. So make sure you answer the question how it was asked. It asked what is the percentile. So your answer should be in terms of percentiles. You don't want to have like it's in the 1.5%. Okay, answer it as a percentile because that's how the question was asked.